Circle. Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel. This is Junior Advanced Session 6 Lecture Note, and the topic is place values. So let's look at a place value chart. It will look like this. So it start with the millions place, 100,000s, 10,000s, thousands. We're just going to keep on going down. Hundreds, tens, and ones. And right after the ones, there would be a decimal point, which kind of looks like this in a real number. Then you would keep on going down and down. Tenths, hundreds, thousands, 10,000s, 100,000s, millions, and you can keep on going on. So now that we know all of the place values in a place value chart, let's try these two examples. Let's look at example 1. Example 1 says, find the place value form in the number 354.7. So let's see how this number would look in a place value chart. Well, 3, which stands for 300ths, would go in the hundreds place right here. So there'd be a 3 in here. And then the 5 for 50 would go right here, 4 in the ones, and 7 in the tens place. We know this because there's a decimal point. It's the number right after the decimal point. So it would be the tenths place. So let's write this number in place value form. So first, let's look at the hundreds place. There's a 3. So this 3 stands for 3 hundredths, or 3 times 100. Then, right after that, there's a 5, which stands for 50, or 5 tenths, which is equal to 5 times 10. And there's one more, 4. So 4 would stand for 4 times 1, because there's 4 ones. And last, there is a 7, which stands for 7 tenths, or 0.7, because it's in the tenths place. So that would be 7 times 1/10, or 0.1. Now what we need to do to all of this is put this in exponents, and mainly these right here. So the first one is 3 times 100, and we can write 100 as 10 to the power of 2. Here's a trick. You know that it's 10 to the power of 2 because there are 2 zeros. This only works for some of the place values. Then let's look at this. 5 times 10, which would be 10 to the power of 1 because there's 1 0. Then let's look at this here. 4 times 1, which is 4 times 10 to the power of 0. And you can also solve this because it's going down. 2, the exponents are going down. 2, 1, and 0. So what do you think is going to be next? -1. So that would be 7 times 10 to the power of -1. So that would be how you would write this in place value form. Now let's look at example 2, 600.08. Now this might seem to you a little tricky because there are so many zeros. Well, really it's not. Let me show you how to do it. There's a 6 right here, which stands for 6 hundredths, or 6 times 100. And we know that 100 is equal to 10 to the power of 2. So you would write that down like this. Now there's a 0 here. So what do? It's easy. You just write the 0 just how you'd write any other number. 0 times 10 to the power of 1, since we already know that. Then there's a ones place, which is equal to 0 times 10 to the power of 0. And then there's a decimal point, so the next place value would be the tenths place. So 0 would be in the tenths place, which is equal to 0 times 10 to the power of -1. And then there's an 8 right here in the hundredths place. So you write the hundredths place like 0 times 0.01. So that would look like 8 times 10 to the power of, well, we're going down, so it would be 2, 1, 0, -1, and -2. So this is how you would write it in place value form. Now let's move on to comparing decimals. Let's look at the first problem here. Which is greater, 0.5 or 0.37? Before you start to compare, you first have to convert 0.5 and 0.37 to whole numbers. But it honestly doesn't matter which number you start with. In this case, I'm going to start with 0.37. 0.37. To convert to a whole number, you have to start at the decimal point and find out how many times you have to go to the right until you get to the whole number. 1, 2. So in this case, we have to go 2 places to a right. And we know that when we go 1 place to a right, we're basically multiplying by 10. So that's times 10. And this is also times 10. So what we're basically doing here is 0.37 times 100. And 0.37 times 100 is 37. Now remember that you always have to multiply the same amount of places that you do for both numbers. So let's look at 0.5 here. We know that we only have to convert once to get to a whole number, but in this case we convert twice since we did it to this one. So that's 1 and 2. So that's also times 10 times 10. We know that 0.5 times 10 is 5. So 5 times 10 is 50. So what we're basically comparing here is 50 and 37. Which is greater? Obviously 50. So in this case, 0.5 is greater since it converts to 50. Now let's look at the second problem here. Arrange 1.001, 0.002, 0.3 from least to greatest. To do this, we have to do the same thing we did in the first problem here, convert to a whole number. Now, as I told you before, it doesn't matter which number you start with. So I'm going to start with 1.001. 1.001. So let's count how many places we have to go starting from the decimal point to get to the end. 1, 2, 3. So that means we multiply 3 times by 10. Times 10 here, times 10 here, and times 10 here. So we're basically multiplying 1.001 by 1,000, and we know that's 1,001. And we know that we have to multiply 0.002 and 0.3 by 1,000 here. So to speed the process, I'm not going to show you how to do this. And I'm just going to multiply 0.002 by 1,000. So 0.002 multiplied by 1,000 is, well, we move 3 times to the right. So it's 1, 2, 3. So that means it's equal to 2. So now let's go ahead and do 0.3 here. 0.3. We multiplied that by 1,000. We know that we only need to move 1 place to the right to get to a whole number. So we move 1 place to the right and we get 0.3 times 10. 0.3 times 10 is 3. And then we have these 2 zeros left, which is 100. So 3 times 100 is 300. Now all we need to do is compare 1001, 2, and 300. Well, we have to compare from least to greatest. So which is the least? 2, obviously. And then 300 goes after that. And then it's 1001. So this is how you would compare. Now let's write it in the decimal form. Well, we know that 2 is equal to 0.002. And 300 is equal to 0.3. And that 1001 is equal to 1.001. So this is how you would order it from least to greatest. And make sure to box in your answers. Okay, now let's learn how to add and subtract decimals. So in order to add and subtract decimals, you need to write the numbers vertically so that the decimal points aligns. So let's try these 2 example problems. The first one is 45.6 plus 103.26. So like it already said, write the numbers vertically so that the decimal point aligns. So first let's write the first number, or let's write the number with the highest value, which is 103.26. Now we need to put the decimal point here since there's a decimal point here. The numbers before the decimal point, 45, need to go right here. And 6 right here. And since there isn't really any digit here, let's just put a 0. Now all we need to do is simply add. So 6 plus 0 is 6. 2 plus 6 is 8. And make sure to put the decimal point. Then 3 plus 5 is 8. 0 plus 4 is 4, and 1 plus 0 is 1. So if you're adding this, you would get 148.86. Now let's try an example where you subtract decimals. 55.555 minus 7.777. So first let's write the bigger number. And now we need to align the decimal point, so let's just write a decimal point right here. And the number before the decimal is 7, so that goes over here. And then the 3 numbers over here. 7, 7, 7. So basically we just subtract. Now 5 times 7, so you would just take here and you get 15. 15 minus 7, 8. So you get 4. 4 minus 7, take again, 7. Make sure you put the decimal point. So you get 47.778. Let's check our answers to make sure. 47.778 plus 7.777. And you just simply add like how we did over here. So 8 plus 7 is 15. You carry the 1. You just normally add and check your answers. And we did get 55.555. So the answer is 47.778. Now that we know how to add and subtract decimals, let's try this example word problem. On a sunny morning, Christopher rode his bicycle to a farm that sold baskets of eggplants for $5.89 each and baskets of coconuts for $7.46 each. How much did Christopher need to pay if he buys a basket of each? So we know that Christopher buys a basket of each. So baskets of eggplants cost $5.89. So let's write that down. And we don't really need to write the $sign right now. And we're adding the amount of one basket of coconuts, which is $7.46. Once again, you do not need to write the $sign yet. If you want to, you can. So now we're just going to add normally and align the decimal points. So $7.46 plus $5.89. So you would just normally add 6 plus 9 is 15, carry the 1, and then you would get $13.35. So make sure to add the $sign. So you would get $13.35 as the total amount that Christopher pays. Now let's look at multiplying and dividing decimals. Let's start with multiplying. Multiplying decimals. 2. Multiply decimals, you multiply the numbers as if there were no decimal points. Then you count the number of digits to the right of the decimal point in all. Then insert the decimal point as many places as counted above. Knowing this, let's go ahead and do this example problem 3.14 times 2.7. So we multiply the numbers as if there were no decimal point. So I'm going to go ahead and multiply 34 and 27, since you don't include the decimal points. So we know that the answer is 918. Now let's look at the second step. Count the number of digits to the right of the decimal point in all, then insert the decimal point as many places as counted above. So, how many digits are there to the right of the decimal point? 1, And over here, 1, 2. We do it for both since it says in all. So we know that there are 2 digits, so we just count backwards, 2. 1, 2. So the decimal point goes right there. So 3.14 times 2.7 is equal to 9.18. So now let's look at dividing decimals. To divide decimals, you do division as you do with whole numbers. Then you place the decimal point directly above the decimal point in the dividend. So, knowing this, let's go ahead and do this example problem. Do division as you do with whole numbers. So, we do 7 after dividing. What you do is place the decimal point directly above the decimal point in the dividend. We know that 7.5 is the dividend, so you place it directly above, which is right here. So that means 7.5 divided by 5 is 1.5. An easier way to look at this is right after you finish subtracting the first digit, just look at to see whether when you're going to the next number, if there's a decimal in between. If there is, make sure to add a decimal before you continue dividing. So in this case, 1.5 is the answer. So go ahead and also do the practice problem for division too. Okay, let's move on to estimating. To round off a decimal, you need to underline the value of the digit that you're rounding. Then you need to look one place to the right and see if the value is greater than or equal to 5. If it is, then you need to increase the underlined value by 1. If not, you should keep the underlined value the same and take off the decimal on the numbers after the decimal. So knowing this, let's do an example problem. Let's round 56.38 to a whole number. The first thing we need to do is underline the value of the digit that we're rounding. So that would be 6 since we're rounding to a whole number. Then we need to look to the right and see if the number is greater than or equal to 5. Is 3 greater than or equal to 5? No, it's not. So you would eliminate this and just keep 56 the same. So 56 is the answer. Now let's learn about change between fraction and decimal. So first, let's do an example, 3/5. So we need to change this fraction to a decimal. It's actually pretty simple. The first thing we need to do is just divide 3 by 5. Like this. And you would bring the 0 down, and you would get 0.6. So that would be the answer. Now let's learn about change between decimal and fraction. So it's the opposite. So the example is 0.4 over 2. Well, what we need to do is first make sure that the numerator and denominator are both whole numbers. But 0.4 is not a whole number. So what we need to do is change it to a whole number. So we need to multiply 0.4 and 2 to a number that will cause this into a whole number. So what times 0.4 will change it to a whole number? 10. So 10 times 0.4 is equal to 4. And 10 times 2 is equal to 20. So 4 over 20. Now we need to simplify 4 over 20. Well, when you simplify, you would get 1 over 5. So that would be the answer. Now let's look at this word problem given to us here about decimals. So let's read this. If the product is 42.63 and one of the numbers are 2.1, what's the other? So let's write this down as an equation. Well, we know that 42.63 is a number that is equal to, so we can write this. 0.1 is one of the numbers, but we don't know what the other one is here. So another way to find this is by actually dividing the product and this number together. So we divide 42.63 and 2.1 to find out what this is equal to. And there is actually a different way to solve this, and I will explain why. So let's go ahead and first try to solve. So what we basically do is 42.63 divided by 2.1. And so there's a rule that when there's a decimal point here, you usually have to turn this number into a whole number. So what do? We move 1 to the right, and when we move 1 to the right, we're basically multiplying 1 by 10. And we do the same thing to this number here. So now what are we basically dividing? We're doing 426.3 divided by the whole number, 21. Now let's go ahead and do that. We know that 2 times 21 is 42. After we subtract, we get 6. And we know that 6 and 21 don't go together for anything, so we just put a 0 here. And after we put a 0, we get 6 again. And we know that we have to bring the decimal point back up here to the same spot, and then we bring the 3 down. 63 divided by 21 is 3. So 20.3 is the answer. So the other number would be 20.3. I think we should check our answer here just in case. So I'm going to go ahead and write this down here. 203, because you can forget about the decimals when you're first multiplying, times 21. Let's see if that equals this number here. 302,604. Yay, so we do get 4,263, not including this decimal over here. But we need to include it back in. So what do? We find out how much places it takes for it to be a whole number for both of these. So here it's 1 time, and then here it's 1 time. And we add this together and we get 2. So we go back 2, and we place the decimal point right here between the 2 and 6, right? So now we know that 20.3 is the right answer. Therefore, that's the right answer here. Thanks for watching!
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!